Now, you have solved a few simple log equations already because you've had to find y-intercepts of log graphs. So when we had a log graph, no matter how complicated it was, no, I don't have an equals. Let's just do x plus 1 in brackets here, minus 3. If you had that log graph and you had to graph it all, and you had your vertical stretch, and then your horizontal translation, and then vertical translation, if you had to label the y-intercept, you had to plug in 0. Sorry, for x-intercepts. Y-intercepts were easy. For x-intercepts, you'd have to plug in 0 for y. And if I plug in 0 for y, we had to get x by itself. Now, the idea here is going to be the same for when we solve more complicated log equations, is we want to get the logarithm by itself. In this case, I can move the 3 over, then divide by 3. We want to get the log by itself. The reason we want to get the log by itself, so this is the important step, the log by itself, because that leads to the next important step, which we can use the definition of a logarithm and change from log form to exponential form. What's the base? The base is 5. I'm going to change colors here. What's the exponent? The exponent is 1. What's the answer? X plus 1. And if we change it to exponential form, all of a sudden, it looks really easy. X plus 1 equals 5. Move the 1 over, and you solve for x. So these questions you've done already, because in our graphing, you had to find your x-intercepts. And so you had to set y equal to 0. So we've had some basic solving log questions already. The key is this step that we get things to a single logarithm and then change to exponential form. So if we want to summarize that, number 1, we need to get a single logarithm. Number 2, use the definition to change to exponential form. Once you do that, it's going to be easy to solve for x. And something that's new is sometimes when you do this process, you get answers that appear to be right, but that actually don't work. Those are called extraneous roots. An answer that appears to work, but when you actually check it, it doesn't work. And so we have to end by checking for extraneous roots. I'm going to put in brackets with that check for extraneous roots that you're not allowed to take the logarithm of a negative or 0. But these first two are the key ones. You need to get a single logarithm so you can change to exponential form. That's what you have to study and make sure you know. Because if you have that in your mind, then you can solve any question where x is inside of a logarithm. So this one, it says solve. The x, it's inside of a logarithm. So I know I need to get a single logarithm. But right now, can you see that you have 2 logarithms? how could you possibly combine log 3 of 9x plus log 3 of x? And this is where all of that practice with expanding and combining things that we did earlier in the unit comes into play. Because we have a log law that says if you have a log plus a log, you can combine it to be a single log with multiplication. So the left-hand side here just becomes log 3 of 9x times x would be 9x squared equals 4. And now we have a single logarithm. We can use the definition and change to exponential form. The base is 3. The exponent is 4 equals 9x squared. And it changes it always into an equation that's easy to solve for. Well, 3 to the 4 is 81. I could divide both sides by 9, and I would get 9 equals x squared. And when you square root both sides, you get plus or minus 3. So we solved for x. Now, in solving for x, one answer is plus 3, one answer is negative 3. We have to check those in our original equation because we can't take the log of a negative number. When you plug in 3, you would have log 3 of 27. That's fine. 27 is a positive number. Then you would have log 3 of 3. That's fine. 3 is a positive number. But when I plug in negative 3, I get log 3 of negative 27. And it just has to have a negative log once for you to put an x through that to find out that that one is extraneous. And the only possible answer is 3. For verifying the solution, we're just going to leave it. If you plug it in and it's positive, it's going to be fine. I mean, we could do mental math here if we wanted. Log 3 of 27, 3 to what exponent is 27? 3. Log 3 of 3, 3 to what exponent is 3? 1. 3 plus 1? 4. Perfect. Okay, so questions for practice on this one are 3, 4, and 9